Hello friends, welcome to a new algorithm of machine learning. Very interesting and lot many modification statistics are available in this algorithm. We term it as support vector machine. Now one of the popular algorithm because of it is coming under the kernel trick category. With the help of kernel trick we can achieve accuracy in different kind of models. Okay, let's see what do you mean by support vector machine. It's a supervised machine learning algorithm which can be used for both classification and regression challenges. However, it is mostly used in classification problems. So in this presentation, I'll be showing only classification system, but make sure that this algorithm is used for regression algorithm also. In this, we plot each data point as a point in n-dimensional space where n is the number of features you have, with the value each figure being the value of the particular coordinate. Then we perform classification by finding the hyperplane that differentiates the two classes very well. Okay. Generally, SVM considered to be a classification approach but can be employed for both problems. It can be easily handling the continuous as well as categorical features also. It constructs a hyperplane, a multi-dimensional space to separate different classes that we have already seen. Okay, this idea is to find the maximum marginal hyperplane that best divides the data set into the classes. See this. So this diagram will perfectly identify how exactly support vector machine works. So I am having two different features of the data. So x1 feature is on x-axis and x2 feature is on y-axis here, and then I have plotted all these points on my plane. So red belongs to one class and green belongs to another class here. Okay, now make sure that if you want to differentiate these two classes, so I can have a line like this. So it's plotted over here, but remember this is what linearly separable data is available here, and I can plot the line like this here also. I can plot a line like this also. But why this line is chosen? There are certain parameters which are mentioned over here. This line is having maximum margin. Now maximum margin means on this line which is the nearest point from this positive part of it and which is the nearest point from the negative part of it. So this is the red which is on the boundary from this particular class, and the green point is this which is boundary from this particular class. These 2 points are called as support vectors. These 2 points are called as support vectors. They decides the boundary, and the difference between these two is called as the margin. And when we put a separate hyperplane, this is your line which is perfectly separating it, and on that line where maximum margin has achieved, if you put it like a straight line, then maximum margin can be different. If line is like this, margin can be different, but this separation is creating a perfect margin, maximum margin that will have between the support vectors of these two classes. So wherever you are getting a maximum margin, that line is chosen to separate the classes. This will be done only for the classes which are linearly separable. So linearly separable classes are separated by this mechanism, and two different classes can be separated. And now afterwards, when you are going to do the classifications, only the support vectors are checked against the classification or against the data set wherever they are, again they are in positive hyperplane or in the negative hyperplane. So based on this, the classification system will identify a new data will go in which particular class. Now few definitions that to remember: support vectors are the data points which are closest to the hyperplane. These points will define the separating line better by calculating the margins. These points are more relevant to the constructor of the classifier. Hyperplane is a decision plane which separates between the set of objects having different class membership, and the margin is the gap between two lines on the closest class points. That's what we call as support vectors. This is calculated as the perpendicular distance from the line to support vectors or to the closest points. If margin is larger between the classes, then it is considered a good margin. A smaller margin is a bad margin. Okay, so that's how classification system is behaving for linearly separable space. But why the SVM is so special? Now let's look at a classification problem. I'm having two different classes in my system. The first one is the apple class and second is the orange class. Now if I want to create a classification model to separate how apple is and how orange is, then I'll create something like this. See, so all the apples, their properties are plotted here. They are in red color, and all the oranges, their properties are plotted like this. They are in the green color here. So these are the oranges and their properties are, sorry, these are the apples and their properties are here, and these are the oranges, their properties are present here. And we are having a support vectors, these two are the support vectors, and here we are achieving the maximum margin between them. So in this way a separable plane is formed, and next time when we are going to do the classifications, we will be comparing it against the support vectors, and which particular plane it will go, that will be identified, and classification system will work perfectly in this case. Now my problem is okay, why support vector machine is effective. Now let's see, support, what do you mean by support vector actually? See, this is the apple, but while classification our apples were different something, and this is the orange. Look at that, this green color is there, remaining others are almost orange colors, and this is the orange colors, and remaining others were green color, almost green and the radish colors. But these points are plotted on the support vectors. So support vector are present at the boundary of this particular class. Okay, so though it looks like orange and though it looks like apple, they are in their original classes and they are called as support vectors. So the exceptions can be considered as support vectors, and we are comparing against them. That's why the classification system in SVM resulting the better results than any other kind of algorithm. Okay, that's how the classification system works in the support vector machine here. Okay, so how it exactly works, we'll go in detail and talk about the disadvantages and what facilities that SVM has provided, that also we'll see. Their main objective is to segregate the given data set in the best possible way. The distance between either nearest point is known as margin, and the objective is to select hyperplane with the maximum possible margin between support vectors in the given data set. SVM searches for a maximum marginal hyperplane in the following steps: generate a hyperplane which segregate the classes in the best way, and select the right hyperplane with the maximum segregation from either nearest data points. Okay, now see this few more applications I am showing over here. This is how the separations are possible. If I am having this red and green, I can have this line, or this line. So perfect line is this that I can create here, and after line is chosen, then margin and the support vectors are identified. Support vectors can be multiple also. In this case we have two support vectors here, and for this class we have single support vector. So line can be in this direction also, or any direction linearly separable space can be created. Now this is how simple algorithm is there, but the important part over here is, if the data is not perfectly linearly separable, then what to do? Some problems can't be solved by using linearly separable space. In such situations, SVM uses a kernel trick to transform the input space into a high dimensional space, shown on, okay, here I'll show you on the next point. The data point are plotted on x-axis and z-axis. Z is a squared sum of both of x and y. Now you can easily segregate these points using the linear separations. Now look at that. If this is what we call as non-linear or inseparable spaces. If you are having the data something like this, this can be done. Okay, just we can write a line over here, or if some points like this are present here also, then what to do? Okay, classes are perfectly done, but how I can create a model, build a model that will perfectly separate a class A or class B from the others. Now if data points is like this, this is by drawing a single line, it is not possible to separate these data sets. So what to do in these cases? So for such kind of cases, I can use the high dimensional mapping. Look at this. This is two dimensional mapping I am using. So x1 and x2. So I'll use one more dimension to that, which I have shown here, z, x square and y square. Okay, square sum of both. After this two dimensional space, if I transform into three dimensional space, it may look like something. Yes. So here we'll not have a line, we'll have a hyperplane in that case. See, so all the red are coming in this x1 and x2, and all the green are coming in this z and x2. Okay, so they are separated. So these all points are separated from this space to this space, like this. Check it out. But it will not work always in this particular way. If I am changing my mapping function, then classification system can be separated. High dimensional space we can convert into, low dimensional space we can convert into high dimensional space, and then separations are possible. But at what dimension you have to look for. Means this is third dimension. You can go for fourth dimension, fifth dimension, sixth, seventh, eighth, go on using it. Now as you increase the dimension, your speed of classification system will drastically reduce, and this can be considered as one of the slowest algorithm for classification system. So it will not be chosen. Then what's the solution on this? Now the solution is the using a kernels. The SVM algorithm is implemented in practice using a kernel. The kernel transforms input space into the required form. It uses a technique called a kernel trick. Here the kernel takes a low dimensional input space and transforms into high dimensional space. In other words, you can say that it converts a non-separable problem into a separable problem by adding more dimensions to it. It is the most useful non-linear separable problem. Kernel trick will help you to build more accurate classifier. So what do you mean by kernel? Kernel are the functions. This function transforms your data from original form into another different format where separations are possible. Now linear kernel, the method and mechanism of SVM we have seen till, they were using the linear kernel. Means linearly separable space. Directly we can separate that, and an equation of line can be used to create that line. Second is polynomial kernel. So polynomial kernel is also used by transforming your data in polynomial format. RBF, radial basis function kernel, that is Gaussian kernel that we generally call. With the help of this also, it's very regularly used kernel that we'll use. Then the last one is sigmoid kernel. They are the commonly 4 used kind of kernel in SVM. Along with that, many more kernels are there, but from the practice point of view, we are going to make use of these 4 kernels, and better results can be achieved by this particular 4 kernel tricks. Linear we already seen. Let's go for the RBF kernel. Radial basis function kernel is a popular kernel function commonly used in SVM classification. RBF can map an input space to infinite dimension space. Infinite dimension space. Check out the function used here. This function is k of x and x of y. This find the distance between x and the center of that particular point, that is x of I, is equal to exp of minus gamma into sum of x minus x I square something. So here's gamma is a parameter which ranges from 0 to 1. A higher value gamma will perfectly fit the training data set, which causes overfitting. Gamma 0.1 considered to be a good default value, and value of gamma needs to be manually specified in the learning algorithm. Now this seems complicated. Let's somewhat simplify it with the help of the graphs and the diagrams. Okay, this is my function. I put into mathematical format now, not in the statement format. So the center point and the original data point to be classified, their distance we are calculating by this particular formula where gamma is present. Okay, that gamma value can be anything default. Now let's see how it does it. So this particular function that we call as RBF function transforms the data into multi-dimensional space, something like this. Check it out. Here in this particular space we have x-axis, x-axis, y-axis and the z-axis. So when you plot it, it will be something like this. Okay, and now I want to predict the value for a particular feature. So based on that, for example, here one point is present and here is one more point is present. I want to classify them in which particular class they will go. So the distance of this will be calculated by this particular formula. Here I will not go much in detail, but the distance is calculated, and after the distance is calculated, we'll be classifying that in one of the classes. So this is the nearest point where this value will be so much close to the 0, and this is somewhat away from the original point, center of the kernel. So its class can be perfectly different in that particular case. That is what we call as RBF kernel. It is very complicated things are involved in statistics point of view, but this kind of mechanism is used to transform your original input data into the high dimensional space data. Okay, this is how RBF will work. Now look at that here. If okay, so this is how I'm using 3-dimensional space over here. Check it out. This data I'm transforming in this particular format. So the data present at the center of it, this is how the center of data present, that will be present around this, only on that. Now this point which are above in the 3rd dimension, they are generated with the help of the function. If it is there within it, then it will be classified as the green. Okay, now if you change this particular area, so maximum maximum area will be covered by this particular function here. Now red, when this is not under this particular cone, it will be classified as a red. Okay, so this function transforms the data in this particular format. After that, it's possible to perform the classification of the new data in a particular class here. Now this is how simply in general way the RBF or radial basis function perform the operations. The advantage of that is if you are having some more randomized data into it, then also it is possible to have the RBF kernel applied perfectly. So let's say this. Now the classes are something like this, in this way. Okay, so for this case I am having the simplified formula created for this. The distance for first this round, the formula is something like this first, and for second it is like this. Okay, and the function devised by SVM will be like this. It's in green category when addition of these two is greater than 0. It is in red category when addition of these two distances is equal to 0, like this, in this way. So RBF kernel is having facility that it can solve the complex problems also by creating a perfect model of the statistics using the radial basis function, and then classification system will work and it will perfectly classify your data and generate the most effective outputs out of it. Okay, so RBF is not only the single kernel, there will be using sigmoid kernel, polynomial kernel also. So for RBF kernel I will be using this formula, as we have seen this, in this way transform the data. We have seen sigmoid, now we are going to see sigmoid. So sigmoid kernel or sigmoid function we have already seen in the logistic regression. Logistic regression is a classification model by which it works on the probabilities, probability study. So here also probability is identified, and based on the probability we are going to make the classification of the data here. So sigmoid kernel is containing this formula, and based on that we will have the curve something like this. So based on the probability of the classes we are going to make the classification of the new data, just like logistic regression we are going to make use here. If you are using a polynomial kernel contain the degree in n, means it will go on 1, 2, 3, 4, 5. It's just like linear kernel contains degree 1 and polynomial kernel contains degree 2 onwards all. So here I am using a degree like d. Okay, and based on that such kind of the models are possible. So we can make some here and some here. Based on that degree, as we change the degree we try to fit it more accurately in two different classes, and classification system can do the accurate predictions after that. So these are the statistics model used by different kind of kernel. When we use the support vector machine, that time we have to supply the parameter called as kernel. So which kernel we will be using for the classification. So if you consider scikit-learn, sklearn, there is default kernel is RBF, which is used to classify the data. But maybe if the data is very complex, it will take some time to perform the classification. Not classification, it will take some time for training. Classification can be done effectively, but training needs some more time than any other kind of machine learning algorithm here. Okay, so these are the type of kernels that we'll be using in the machine learning. They are not only the same kernels available, but many more kernels are there. I'll just show you this. See, there's a website called datafreakankur.com. So this is created by one Indian developer, where they have mentioned the different kind of kernels. Look at that. This is polynomial kernel, how it transforms the data in which particular input space. Okay, so this is Gaussian kernel. Check Gaussian kernel. This is Laplacian kernel. Their formulas are mentioned over here. Here also the K formula is mentioned. This one. This is what Gaussian kernel RBF we have used. Laplacian kernel. Yeah. Then sigmoid kernel. This is sigmoid kernel. Okay, sigmoid kernel. Okay, how it's separated. Chi-square kernel, like this. Periodic kernel. Check it. This is periodic kernel. And okay, that's it. These are the different kernels used in the classification models. But kernel SVM supports only 4: linear, RBF, sigmoid, and the polynomial. And now let's go for using our applications. So for this particular applications, I have chosen very interesting data set created from OCR. Look at the OCR software. We are having hardware there. There's a pinpoint, it reads the data. There's a OCR article on Wikipedia shown there, and it's reading that by using a pen. We read that it read the data in the form of a picture, that particular characters in the form of picture, and their dimensions are recorded into a software, OCR software, and then OCR software predicts what kind of character is that, and the data is taken from this kind of the device that we are going to use it here. Now, how to do? The image processing is used here, so it's a difficult task for many type of ML algorithms. We already seen this system in decision tree and random forest also, where I'm going to predict the banknotes are fake or not fake. So this is almost one or more example where I'm going to apply the image processing systems here. So the relationship linking pattern of pixels to higher concepts are extremely complex and hard to define. For instance, it's easy for a human being to recognize a face or a cat or a letter A, but defining these patterns in strict rules is difficult. Furthermore, the image data is often noisy. There can be some slight variations. Some images were captured depending upon lighting, orientation, and positioning of the subject. Look at this image I have shown here. These all are A, these all are B, these all are C, these all are F. Now try to distinguish or try to find the common properties in all of these letters in single row. It's difficult. Okay, so what we are going to do, we are going to scan these kind of different kind of A letters, different kind of B letters, and their dimensions that OCR software has recorded. They are saved in a CSV file. When OCR software first processes a document, it divides the paper into a matrix such that each cell in the grid contains a single glyph, okay, which is just a term referring to a letter, symbol, or a number. Next, for each cell, the software will attempt to match the glyph to the set of characters that it recognizes. Finally, the individual character would be combined back together into words, which optionally would be spell checked against the dictionary in the document's language. Now, the data set is here with me. Check this. So, this data set available with me. So, when I have scanned a letter and its properties from OCR software are recorded. These are the properties. X box, Y box, width, height, on peaks, X bar, Y bar, like all. Many properties are present there. See, for a particular letter, many letters are there. Maybe the letters are duplicated. See, this is G, and this is also G, and this is also G. So different things are. This G is different. This contains here 3, 4, 4, 6, 7, 9, 4, 6, 5, 4, 5, 6, 2, 3, 6. Is there any similarity? Not actually. No similarities are present. Then how it is possible to identify this particular G? So my task is, when OCR software reads a character, I want to predict which letter is that. Now I'll feed this data into the model of support vector machine, and based on that I'll do the prediction what letter is that which is now scanned from the OCR software. Okay, now let's see. It's very big data set actually. This is letter is your output variable, and remaining others are the input variables that we'll be using here. One more important things that you need to remember: SVM requires the classification, SVM requires the pre-processing, that is, we need to scale your data, but this data set is in the same range. That's why I don't have to pre-process this data. So if it is having different ranges in thousands and in tens, 20s, and one in lakhs, in 10,000s, then it's required to pre-process the data. Now it's don't require the pre-process, but in general SVM require the pre-processing. Okay, so it's very big data set. Check it out. It's going about 10,000, 20, 30, 14, 15, 16. Oh yeah, very huge amount of data is there that we are going to see it over here. Now let's see. Data is collected, and now we are going to do the prediction with the help of our algorithm of machine learning. So let's see. I'm going to use this data from our data set, MITU's repository. It's available on UCI machine learning repository also. From there also you can use it. So let's see how to classify this and do the predictions. Let's import the pandas, and after that my file name is letterdata.csv that I'll be reading. Okay, read, check out the shape. Yeah, 20,000 rows and 17 columns are there. 20,000 rows and 17 columns are present. So out of 17, 16 are input and the letter is the output. If you see the head of it, see that data is perfectly read. Letter, X box, Y box, all. Letter is the output variable, and remaining are the input variables that we'll be using onwards. So let's check. input variable here, and see 26 total letters are there that we have seen. Set of y, so only individual letters will be fine. We know that total 26 letters are there. If you see this, so 26 letters are present that we are going to classify, and how many are there that we can find by using len of y. Okay, so y is separated, that is output variable is separated. Now we are going to separate the inputs. X is equal to data dot drop letter, x is equal to 1. Okay, so I am dropping this particular column and storing in x, and now check, x will contain the input data only, which is containing all 16 different characteristics, 16 different features that your input data set is now having. Yeah, so make sure that all of their features are almost interrelated to each other. They are not having much deviations in the input. So if the deviations are not there, then I'm not going to pre-process this data by using scaling or the normalization. So I will directly go to split my data into train test format, and then we are going to see how the classification system will work. Now let's see, I've imported train test split. So data is very huge, it contains almost 20,000 entries. Out of 20,000 entries, I'll keep 4,000 entries in test data set. Okay, means 20% entry I'll keep in test data set. So x train, x test, y train, y test, train test split, give x y input, test size equal to 0.20, means out of 20,000, 4,000 entries will go to test data, and keeping random set 0, so our randomization will be same. So I splitted this, and now let's check the length of training data. It must be 16,000, test data is 4,000. They are separated, they are randomized. If you see the original data set, that also it is not sequentially stored, it is randomized data set. Again it is randomized, and we are getting the mix elements out of it. Now I'm going to show one more interesting class over here from the collections class. I'm importing a class collections package. I'm importing a class counter. This counter class is used to count the number of entries of a respective data within a particular variable. Okay, how to do this one? So I imported this counter class, and then I have created the object of counter here on y. Y contains 4,000 characters, 26 different classes are there, but how many characters belongs to a respective class, that I can find by using counter. So C object I am creating here, check this, and if I print C, you can check it out. In y, y contains total 20,000. Out of 20,000, how many entries are scanned for character A, how many are for B, how many are C, D, say this one, all. For all Z, almost 700 to 800 these entries are lying in between this particular range. Maximum is 80513, sorry, this one. You scan for max number of times, and the minimum I think it is this, or 736, that is C is scanned. Okay, so within that range almost all they are present, means almost all classes are scattered almost in the same range. That's why I don't want to pre-process this data further to do any other operations here. Okay, that's created. I know that now counter of all the classes are almost equal. By using this method we can check it. We can use for other classification problems also. Okay, fine. Yeah, now let's go for algorithms used here. From sklearn.svm package. So svm is the package in sklearn. From there I am going to use svc. So in svm package, two classes are the svc for support vector classification and svr for support vector regression. So I'll import svc from there, and then I'm going to make use of the kernel methods here. Imported the class. Here svr is also present. If you want to perform regression model on sv support vector, so we will be using svr. All three letters are capital. So classifier, let's create the classifier. Classifier is equal to svc, kernel is equal to rbf. Rbf means radial basis function I'm using, so I don't use this. Let's try with linear kernel first, and random state is equal to 0. So I'm creating the object of svc by using the kernel linear. So here I can pass all four parameters. I can have linear parameter, rbf parameter, poly parameter and sigmoid parameters. Okay, so wherever it is matching, it will take that data, and based on that the model of support vector machine will be created. Okay, so SVM is created. Now let's fit it. Classifier dot fit x train y train. So I'm fitting it. Total 16,000 entries are present. Yeah, it is taken almost 3 to 4 seconds to train, and you can check the complete output of this particular object created here. Okay, so linear kernel, random state 0, these are the most important parameter I'll be using here. Here I'm not using probability because linear kernel don't have probability, only sigmoid kernel will have the probability here. Okay, so let's fit it, and now let's do the prediction on the test data set. So classifier dot predict x test, 4,000 entries are present in x test. I am applying my trained classifier on this data, and now generating the predictions out of it for again 4,000 entries. Let's see. Yeah, that's done. ypred is containing the prediction, 4,000 prediction for the remaining 4,000 entries, and now let's print the confusion matrix here. So let's import the confusion matrix and print it. Wow, so complicated. Why? Because 26 classes are there, and the matrix generated is 26 by 26. I'll just reduce the length. Okay, check this out. It's very big, so it's not possible to fit within this particular area. I'll use some other method to print the confusion matrix that can be chosen here. Now let's go for that. It's very big matrix generated. Okay, so what I'm going to do here, from cborn there is a function called as heat map. With the help of heat map, cborn is also one of the graphical visualization model which is used to visualize the data in more different, with the help of different kind of the graphs. So I'm importing cborn. You need to install this cborn from your Anaconda or by using the pip as SNS, and matplotlib also I imported, matplotlib.pyplot as plt. Then I'm giving a figure size as 16 by 9 resolution here. Now confusion matrix which I have generated for y test and ypred, I am saving in a variable mat. Okay, this is the matrix which will be generated from this. I am storing in the variable mat, and now I want to show in graphical format. How to show that? SNS, that is cborn.heatmap mat.t. So basically this matrix is generated in what format? Actual and predicted. So I'm making actual to predicted, predicted to actual. That is what I'm doing, transformation, that transpose of it. Okay, so once this is done, then I'm going to make square true, annotation true, fmt t, and the color bar is false. Okay, now on x side I'm having true labels, that is test values, and on y side I'm having predicted labels, that is what? Predict values. Okay, and now see how this confusion matrix looks like in more graphical and perfect format. Okay, so let's run this again. Okay, it's taking some time. Yeah, perfect, printed now. Now check this, predicted values from this side and actual values from this side, y test, and this is showing your matched values. Let's go for one of the labels here, 0, 140 are matching, and remaining these are 1, 2, 3 whatever are 0 and shown, they are not matching. Okay, and this row is only matching, correct, and they are printed. Now let's see the accuracy of this algorithm now. 86.55%, means out of all 86.55% entries are matching. If you see the classification report, then you can easily find. A class contains A category 147 are there in out of 4,000, but 95% are matching. B are 83% matching, and 158 is the support of it, and then go on using it. Check it out. Almost everywhere we are having above 80%. Only H is not having 80% accuracy here. Remaining others, so even S also 68% accuracy, and remaining others are almost above 80%. Okay, fine. So highest is, I think it is 95% for a few of the classes. They are matching, but nowhere we are achieving 100% accuracy. Correct. Overall accuracy is 87%. Okay, it's fine. We can achieve good accuracy by linear kernel, and classification system is working correctly. Yes, this kind of kernel can be used. It means that this data is linearly separable, but by 87% only. Okay, because I'm using the linear kernel over here, and based on that the predictions are happened, and we got these results that is shown on the screen now. Okay, so what to do? I'm going to change the kernel now. This is classification report that I'm achieving. It's good, acceptable, and but check whether if you change the kernel, is then any changes happens. So I'll make use of RBF kernel now. Okay, let's build. Fine. Okay, it's taking time, more time than linear kernel. Yeah, done. And let's do the remaining predictions. Confusion matrix, print it, report, and accuracy score. What is that? Yeah, 93.35%. Okay. So accuracy of the RBF kernel is 93.35%. It is 6% more than the original kernel of linear. It means that RBF kernel functioning more effectively on this data set. And now let's see the classification report. Okay, fine. Almost everyone is going above 90%. Almost everyone here 85% for H. For P we have 86%, and remaining others are above 90%. So 93% accuracy we are achieving out of it. Yeah, that's fine. It means that rather than linear kernel, the RBF kernel works more perfectly on this particular data. Okay, so that's what the prime results I am achieving out of it. 93% accuracy. Matching power is almost above 90% for all kind of the letters. So easily I can use RBF kernel to do the predictions for this kind of the data set. Okay, done. Then let's change the kernel to another RBF. I'll use polynomial kernel. So let's use poly. Fit. Okay, and it's taking more time. Yeah, done. Predict. Confusion matrix. Print it. So, and check out the accuracy score of it for polynomial. Yeah, 95%, perfectly. It's going above all. So polynomial kernel is having 95.425% accuracy. It's more than the RBF kernel now. And now check the classification report. Yeah, perfect. Now everyone is going above 90, but still H is on 89%. Polynomial kernel, great. That's accuracy is great. For A, I'm having 99%. Everything is 99%. See how many are mismatches are there for A. For A, I'm having only 2 mismatches here and here. Yeah, it's predicted as another, and okay, 2 miss out of 147. Only 2 mismatches are there for the letter A. Correct. That's why accuracy is very high, 99%. Here, lowest accuracy is for H only, and that's fine. That's great. 95% accuracy we are achieving out of it. Okay, so and I want to do single entry prediction here. Let's go for that. Okay, based on the accuracy score and time required to build the model, we need to choose the kernel for doing the prediction by using support vector machine. Okay, so let's go for finding an entry. See here, if I want to do single entry prediction, I am having a total 16 columns. So it's very difficult to add 16 columns here. So what I am doing, randomly from training data, I am using some element here like 10,567 number row, and I am converting that into the array format, and then I am reshaping it to 2-dimensional format like in this way. Okay, 2D array I am getting, and now I want to predict what exactly this letter is. So let's predict that. Which is this letter? R. Yeah, so this is R, this dimension fitted to the R. Or if I go to some other, this is D. Yeah, okay, I will take this, and now very small number, this letter is T. Yeah, correct. So single entry prediction is possible on this kind of the data by this method, because entries are more. That's why I am not giving manually one of the random entry from the data set I am taking and making a prediction what letter is that. So when the OCR software is scanning your data, we will take that data in this dimension and will go to classifier for prediction. The prediction will generate the result and will show you on the screen what letter is that, and based on that the word and letters will be formed in your documents and you can save it. This is what the application of data set. One more thing is remaining here. I am not using the 4th kernel, that is sigmoid. Okay, so let's use sigmoid kernel. sigmoid, yes, and fit it. Okay, basically sigmoid kernel takes some more time. That's why I have not chosen that here. Maybe it will take some time to do the classification or to train the algorithm. It's actually if it is not possible to fit this data into this part of kernel, it will take some time, and till then it is not assured that we are going to have good accuracy out of this sigmoid kernel. But as the sequence that we have followed, that is linear kernel is having 86%, then RBF is having 93%, polynomial is having 95%. That's very fine. That's accuracy achievement is very great if you consider, and SVM can be easily used for such kind of the data, but it takes some time there. Yes, sigmoid is trained. Let's go. Prediction is also taking a time. Okay, let's see how much accuracy you can achieve from the sigmoid kernel. Oh, see, it's a 63 here itself, so I think accuracy is not so much good, and let's check it out. Okay, see the accuracy. It's it is 2.9%. Not so, it is not fitted well to the sigmoid kind of kernel in SVM, so it's pretty difficult to use this. Yeah, almost, yeah. Oh, everywhere we are going to have the accuracy 0%. So your A is containing 43 and U is containing 33. That's why we actually accuracy 0.033%, only 2.9. So now sigmoid kernel is not possible, so you can make use of your own any one of the three kernels which is beneficial for you, giving highest accuracy, and you can do the prediction onwards all by this method. Okay, so that's it. That's SVM. One more thing I'll suggest you, regression problem. So if you want to solve the regression problem, SVM contains this regression model also, but rarely it is used. Non-linear regressions, we are having this in support vector regression there. So to do this one, you need to use from sklearn dot svm import svc. The two classes are there, svc and svr. So this svr is used for regression model. So if you want to if you are having output in the continuous formats, that time regression model can be used for building the model and doing the prediction based on the model build. Okay, that's what the support vector machine is. That's from my side. You just practice it and go ahead of using this algorithm. Thank you. Thanks a lot.